of you guys?
How many of you guys did this work?
How many of you guys did this work that I sent? Remember I sent you this paper, the 2022 paper, from the people that are in this meeting. I think the only person that I remember solving this is Shadrach, Samoa, Jerome, and who else is here? Daniel. Daniel, did you submit?
Which one?
The 2022 paper.
The 2022 paper.
No, I didn't.
What happened, you people?
That time. I was doing the assignment, so I didn't have time.
Jerome,
what was the case?
Namba okulondera okutumalira n'okulira bwansimu. Ala kutuma mvono oluse, kutuma mvono ekitundu.
Where is someone? What happened for you?
I started answering, then I stopped. I don't know.
Was it easy or was it hard?
Let me check.
Mr. Mutonga. And I think Mr. Shadrach submitted as well. Okay, so I think I wouldn't like to waste a lot of time, guys. I wouldn't like to waste a lot of time, so I think we can try to go over some of the questions that were in this paper. Yeah, we can try to go over some of the questions. I'm skipping the Morgan's law, guys. You've already gunned this, so I think we will start from B and try to build up from that.
Is that okay?
Is that okay?
Yeah.
All right.
Yes, it's okay.
Okay, so
question one B is saying that determine whether the function given is odd, even, odd, or neither. And the function that they have given us is f of x is equal to x to the power 6 plus x to the power 4 minus 10x squared. So we need to determine whether this is odd, even, or neither. And I think everyone here knows that if f of x is equal to f of negative x, then this function is even, right?
Oh, yes.
And we know that if f of x is equal to negative f of x is equal to negative f of negative x, then this function is odd. Or some of you may write it as negative f of x is equal to f of negative x. It's one and the same thing. It means that the function is odd. We know this, right?
Yes.
So if the function
does not qualify under this or under this, it means that that function is neither odd
Yes, right now.
nor even.
So
with that,
I think
I think we can
try to determine if this
function is odd or
even,
odd, even, or neither. So let's try to check if it is.
let's try to check
Let's try to check if it is even.
if
If it is
even,
even,
f of x
f of x
will be equal to
will be equal to f of
what
negative what
x.
x.
So we need to find
So we need to find what f of negative x is. So you know that f of negative x is just equal to where you see f of x,
where you see
f of x in this original function, you replace with f of we replace with a negative x. So where you see x, you replace with a negative x. And if we evaluate this, you find that what we'll just get is here we'll just get x to the power 6 plus even here we'll get
x to the
power 4 minus 10, even here we'll get x to the power 2, right? I'm waiting for a response. Are we together?
Yes.
Yes.
Yes, we are following, sir.
So
Okay. So this means that this is f of negative x. If we look at f of negative x and you compare it to f of x, you find that these two, this one and this one, they are just the same. Okay. So I'm saying that f of x is equal to f of negative what x. Then your concluding statement should be that since f of x is equal to f of negative x, the function is even, right?
Yes, sir.
so this one was very simple.
So this one was very simple. We can
we can move from it.
yeah, we can move from it. It was very simple. So I hope I haven't left anyone behind.
Okay, so now
when we go to C,
guys, should we do C?
Don't you know how to solve C?
Let's do it.
Okay, so we're saying that root 10 is irrational. We need to prove that root 2 plus root 5 is also what? Irrational. We need to prove that this is also irrational. So how do we do this? So we prove this by method of contradiction. And please guys, when you're answering questions on irrational numbers, don't forget that starting statement. It carries marks. I think those of you that submitted the 2023 paper and you forgot the statement, I used to tell you that the statement is very important. So don't forget that statement. So you need to put up that starting statement. So we'll say we prove by contra spellings, contradiction
by
We prove by contradiction by assuming that we prove by contradiction by assuming that root 2 plus root 5 is ration. Okay. We know that if we are assuming that this is rational,
we know that
if it is rational,
then
then
it
it can be expressed
in
the form A over B. And I'm going to end here. You know how this statement ends, guys. If you want, you can say it can be expressed in the form A over B, where B is not equal to 0 and there is no common factor between A and B. You know how that statement ends.
So
when you write this statement, it means that you are saying that you can write root 2 plus root 5 in the form A over B. Okay. So now here's the catch. When you are solving this question and they have given you here, they have given us root 10. You need to make sure that this side of the equation, you need to have root 10. You need to get root 10 on this side. Okay, you need to get root 10 somewhere in order for you to solve this. Okay, if they gave us root 5 here, for example, if it was root 5 instead of root 10, we needed to remain with root 5 on this side of the equation in order for us to prove our contradiction. Do you understand that?
Yes, sir.
Yes, you understand.
So how do we get our
how do we get our root 10 since we have this? Well, we can only get our root 10 if we were to square both sides of this statement. And when you square both sides, on this hand side, what you're going to get will be root 2 squared plus 2 root 2 times root 5 plus root 5 squared is equal to A squared over B squared. And the trick I've used here is, remember that one that I usually tell you about. When you have A plus B, this is the same, A plus B in bracket squared, this is the same as A squared plus B squared, A squared plus 2AB plus B squared. You know this shortcut, right?
Do you know this shortcut, guys? Or you just go
Do you know this shortcut, guys? Or you just go manual, like you start this one times this.
I have a question. On the right hand side, yes, I know this. Now on the left hand side,
Yes.
yeah, Shahida.
Yes.
How have you gotten this function?
Which one?
Which one, Jerome?
Which one, Jerome?
The one. How have you distributed? Wasn't it root of 2 plus root of 5 in bracket squared?
Yes.
Oh, okay. Oh, it's okay. I get it.
Get it, Ka? So here, when you deal with this, you just get 2 plus 2. We know that we can combine these according to the rules of radicals. We can write this as root of 2 times 5. We know that, right?
Yes, you know.
Okay, yeah. Plus this one will just be 5.
Okay, yeah. Plus this one will just be 5 is equal to A squared over B squared.
Once we get
Okay.
this,
Once we get this, we can add this one and this one, it will be 7. So we have 2 root. When you multiply these two, you get 10. So it will be 10. It will be 10 plus 7 is equal to a squared over b squared. Okay, so I just want to remain with the root 10 this side. So I'll make this 7 jump to the other side. So I'll have 2 root 10 is equal to a squared over b squared minus 7. Okay, and I'm going to make b become the common denominator. So if I do that, I'm going to have okay, I hope have I lost anyone? How I've gotten this? How are you behind?
You did the common. Okay, it's okay. Again.
You are there, Aga?
Yeah, I see you going there.
Okay. So once you get that, then we can divide both sides by what? By 2, even here by 2. So that this 2 and this 2 cancel. And what we remain with will be?
Is that a question?
Is that a question?
No.
So what we remain with?
So what we remain with will be root 10 is equal to a minus 7 a minus 7b squared over
b squared.
2b squared.
That's
Okay,
what we are.
that's what we are getting.
So here's where the contradiction.
Comes in.
Remember,
we said that if root
5 is
2
rational,
plus
it can be
root 5 is rational, it can be expressed in form of a over b. If we express it in form of a over b, it means that a is rational and b is what? Rational. So in short, this entire thing is what? Is rational. You understand?
Yes. So that it means that entire thing is.
Yes. So that it means that entire thing is rational. We know that 7 is rational. We know that 2 is rational. We know that a squared is rational. We know that b squared is rational. Like I've said, 7 is rational. In short, everything here is what? Rational. You understand?
Yes, sir.
But what we have here, this side is irrational according to what we have been told in the question statement. The question statement says that given that root 10 is irrational, okay, root 10 is irrational. So we know from the question statement that root 10 is what? Irrational. So we can't have an
irrational number
being equal to
a rational number.
Since this side is
rational and this other side is irrational, this is a contradiction. You can't have an irrational number being equal to a what? To a rational number.
So
in short, what I'm trying to tell you guys is that this statement that we have here, the statement that we have written here, is a contradiction. So you can conclude then to say that this is okay, we can say that this contradicts the rationality of and this contradicts the rationality of a root 2 plus 5. Thus
it is irrational. Okay, it is irrational. You know that there are many ways of which you can use to finish up this question as your last statement. Me, I prefer this one because it is short. Mwadishi fimo ifukugana fe, but you at least understand what is happening where, what is happening here. Okay, at least understand what is happening there. Are we clear?
Yes, sir. Yes, sir. We are
So
correct.
can we move?
Yes, sir.
Right. So if you want, you can. I hope you are writing. You're not just listening. Okay. Let me go back to this. I don't want to touch this question. If there is time, I'm going to touch it. Palast, hopefully. Yeah, I'm going to touch it palast, hopefully, because we are going to delay if we touch it. E, I still haven't found the correct. I still haven't found the question that is clear on E. I don't know if you can see the typing error that was here. I don't know if it's a printing error or it's a typing error. But once I find it, we're going to look at it. Okay, so I think we can come here on question 2. Okay. So I think if you look at A is a free mark. Wouldn't you people agree with me that A on question 2 it was just a free mark? Jerome.
On expressing.
Yes.
Yeah, this one was like a free 5 mark.
Okay.
That is according to me. I don't know if others are finding it.
That is according
That
to
one is
Jerome.
known.
That one, it's no 9. Do you want us to solve it or we skip it?
I don't know, but we can skip.
Okay, we can skip.
Because this one just has 3 steps. Because the first question, this one is not followed by the one which is repeating. So when multiply this by 10 will give us a first equation. Multiply that one by 100, subtract. Yeah, it's a simple one.
All right, let us skip. Let's go to B. I think
Maybe others
guys, can you land in? Abena Jerome Abamajo. Others are dead silent.
Let's just move on to the next question.
Right. Okay. So let's go to B. Then B is simple. So we have f of x is equal to 4x minus 3. G of x is equal to x plus 3 over 4. And I hope we can quickly finish this question so that we can do that one, the one I skipped for graphing as our last question. So let's just
So we need to
move
show that
fast.
the two functions
Okay, so we need to
are
show that
inverse
the two
of each
functions
other. So
are
we need to show
inverse
that
of
these two
each other.
functions
So
are
we need to show
inverse
that
of
these two
each other.
functions are inverse of
And
each other.
we know
And
that
we know that if
if f of x
f of x and
g of x
g of x
are
are inverse
of
of
each
each
other,
other,
then
then
f
f
then
then f of g of x is equal to x, right?
and g of
Yeah.
x is also equal to
f
what?
x is also equal to what? X.
So
So
that means that
these functions are what?
inverse
Are
of
inverse
each other. So what we need to
of
do
each
is
other. So what we need to do is we need to show that f of g of x is equal to x and g of f of x is equal to what?
So
X.
we know
So
that f of
we know that
g
f of
x
g of
is
x is just simply
replacing
replacing
g of x,
g of x, replacing this
we
function.
replace it in 2.
We replace it into x, right?
We replace it in f of
We
x,
replace it
the
in
x
f
part
of x, the x part of f of x.
So what I mean is,
Okay, so what I mean is
where there is
we know that f of x is like
now
this.
f of g
Now
of
f
x
of g of
is going
x
to be like this, where there is
is
an
going
x,
to be like this, where there is an x.
where there is an x,
Where there is an x, we are going to replace
G of
with
x,
what?
and we know
With
that
g of x, and we know that g of x is x plus 3 over what?
4.
Over 4.
So this is going to be,
So this is going to be, we know that this 4 and this 4 can do what? Can cancel. We will just have x plus 3 minus 3. This is going to give us x, right?
okay. We can
Okay. We can
move on to g.
We can move on to g of f of x. Okay.
So g of f of
x is the same as where there is x.
In g of x,
you just replace with what? F of x. So it's going to be, we can write it like this, just for demonstration's sake. Just want to demonstrate. It's the same as f of x plus 3 over 4. Okay, where there is x, we replace with the f of x in that original function. Okay, so we know what f of x is. F of x is 4. 4. Is it 4? It's 4
minus 3
minus
4x
4x minus 3, and here we have plus 3 over 4.
So what we're going to get
will be 4x minus 3 plus 3 over 4. This one and this one will cancel. We'll have 4x over 4. This is just the same as x, right?
So you guys
already know this. You guys already know this. Here is where usually most of you fail. Where most of you fail is on the opening statement and the closing statement.
So
the statement that I wrote here is even chatarimpa konokutarimpa. I'm going to send you the solution so that you see how you can write. But even this is okay the way I started. Write something at the start and at the end.
You can say, since
So you can say since
is equal to
x and
the
the functions are inverse
of each other.
other.
Okay,
Okay, are we good so far?
Okay, so we have moved. We have
We
gone to
have
what?
moved. We have gone to what? We have gone to C, right?
We've gone to C.
We have gone to C. Have I left anyone behind?
No.
Okay, so I haven't left anyone behind. We C is saying if
alpha
alpha
beta
beta are roots.
so alpha and beta
So
are
alpha and beta are roots of
the quadratic
the
equation
quadratic equation
3x squared plus 6x minus 15 is equal to 0. Find the equation whose roots are alpha squared and beta squared. Okay, so in short, I think I just I lost connection. Can you guys see my screen?
my screen.
Okay, can you guys
Can you guys see my screen? I think we lost connection for a minute.
Yes, personally I can see.
Okay, all right.
Okay, all right.
So
So we are saying that
we have an
equation which is this one, and it has roots alpha and beta,
and
and we need to find the equation
for we need to find the equation
that has roots alpha squared and what beta squared.
Don't you want to skip
Don't you want us to skip this one?
I was also thinking about the same thing, but I don't know about others.
Let's skip.
Eh?
Let's skip.
Let's just solve it.
Okay,
Let me quickly solve it, Kansh. Okay, so in order for us to find that equation, first what we need to find is alpha plus beta and alpha times beta, right? So
I
didn't get the last person who just spoke.
Okay, so we need to find
alpha plus beta and alpha times beta, and we know that alpha plus beta is equal to negative b over a. Okay,
where we
know that in this quadratic equation that we've been given, this is a, this is b, this is c. Okay, so that will be negative. Our b is 6 and our a is 3. So this will be negative 2.
And
for alpha times beta, we know that alpha times beta is equal to C over
A.
A. Okay, C over A. We know that our C is negative 15
and
and our A is 3. This will give us negative what? Negative 5.
And
we know that every given quadratic equation can be expressed in form of its roots, where we have
x
squared minus sum of the roots x
sum of
the roots x plus
product
of the roots
is equal to 0. So in short, you can express
a quadratic equation where you have x squared minus the sum of its roots x plus the product
roots. So in our case, that will be
x squared minus the sum of the roots that we are looking for.
The roots that we have been given are alpha squared
and beta squared. Don't get these.
These
they already have.
Now we are
considering these, the ones that don't have an equation. So
the sum of those roots will be
alpha squared plus beta squared with
x outside
plus the product is alpha squared times beta squared. Let me write this in red.
Is equal to 0. Okay. So in short, what I'm trying to
tell you is that we need to find alpha squared,
and when we find it, we are supposed to replace it.
And when to replace it here. Jerome.
Jerome is gone.
He's gone.
Daniel, Dave.
Okay, so we need
to find alpha squared times beta squared.
We need to find
alpha
times beta
squared times beta squared. And
we know that
alpha squared alpha squared plus beta squared, not times beta squared. So alpha squared plus beta squared. And we know that this is just equal to alpha squared.
It's just equal to
alpha plus beta
in bracket squared
minus 2 alpha beta. Who doesn't know where this is coming from?
Like
You know.
Jerome.
was bad. But my network was bad. So
Okay.
but the good part is I've done this question before, so I know everything.
Okay,
so we all know where this is coming from. We just replace, right? We're saying alpha squared plus beta squared is equal to this. This is an identity that you can just gun. If you've got time, you can know how to derive it. It's very easy to derive. Okay, so with that, we just need to replace alpha plus beta. And we know what alpha plus beta is. We already found alpha plus beta. Alpha plus beta is -2 squared is -2, and we have a squared there, so hence the squared here, -2. And we already found alpha times beta. Here we found alpha times beta, and alpha times beta is negative what? 5. So this will be equal to what? So be 4 plus 10, right? So this is 14. And since we found alpha squared plus beta squared, we need to find alpha squared times beta squared. And we know that this can be written as alpha times
squared, like this. Okay, and we already know what alpha times beta is.
Alpha times beta is -5.
So we just square.
So we
what we get
just square. What we get will be 25. Are we okay?
You guys have
stopped responding. You didn't want me to solve this question.
We are following.
We are following. Yeah, we are following.
Okay, so we have we have found alpha squared plus beta squared to be 14, and alpha squared times beta squared to be 25. So now all we need to do is replace that in this equation. We need to replace that in this equation, which is x squared minus alpha squared plus beta squared x plus
be 14, and also now we need to alpha squared beta squared is equal to 0. So we need to replace our findings. Okay, network Yambo performance. So replacing our findings, what we get is x squared minus what? X squared minus 14x plus 25x is equal to what? Oh, not 25x. Plus 25 is equal to what? To 0. That's what we'll get when we replace. Are we safe? We move.
Yes. So even at this point, you need to put a
statement, guys. Statements won't even take you. Won't even take 10 minutes of your time, or even 3 minutes of your time. To just be simple. So you say therefore the quadratic equation with the roots alpha squared and beta squared is this. That's your closing statement. You move, you go to the next question. Daddy, I don't need to write that. You already you say therefore the equation whose roots are alpha squared and beta squared is x squared minus 14x plus 25 is equal to 0. Okay. I think we can move.
Repeat the statement, sir. Repeat the statement.
Jerome.
Okay.
Are you saying something?
No, I'm just walking. So let me listen. It's not Mr. Yando. I was saying that you can repeat the statement you're saying that.
I didn't get what
you said, Mr. Shadrick.
It's not like you should repeat the statement
that I should write the statement.
The one I'm saying.
Yes. You want me
Yes,
to write it?
you want me to write it?
No.
I didn't get what
I
you said.
didn't get what you said.
I'm saying that you should repeat the statement if you are saying.
Okay. The statement was.
Okay,
Not
the
right,
statement
just
was
saying it.
The statement
okay.
is therefore
The statement
equation
is
with
therefore
the roots
the quadratic equation with the
alpha
roots
squared and beta
alpha
squared
squared and beta
is
squared is
x squared
x squared
minus
minus 14x
14x
plus
is
25
equal to
is
0.
equal to 0.
Alright. You can proceed.
All right.
All
We
right.
do D or we
We
skip.
do D or we skip.
Do the next one.
Someone has said we skip.
Someone has said we skip.
Which question do you want to skip?
Okay.
D.
D.
Sure that too. Yeah, no, rationalize. Rationalize. Okay, yeah, we can skip, but I just learned the topic, so I'm cementing, but you can skip this one.
The
When
others. You're
the
not
others,
speaking, you
you're
people.
not speaking, you people.
You can do it if there is someone who has assigned with the same question. You can do it just after that.
Let's skip.
Okay. We
Okay,
are skipping.
we are skipping.
Let's skip and answer A.
Okay, let's skip and answer
Let's
E.
skip and answer E.
Yes.
Okay, guys.
Okay, guys, the reason we are skipping is
time
time filafine, like I told
since
you. Since you guys already know most of these things, we have already done these things.
it's
It's better we focus on the things
the
things that are giving you trouble. I think Shadrach, yeah, this is you remember the question you were asking me, rational root theorem?
Yes. So
Yes.
So
this one
this one involves rational root theorem. Yeah, it involves rational root theorem. Okay. So the question is saying solve this using rational root theorem.
and
And we know this is a polynomial, and we need to solve it, meaning we need to find the values of x.
and
Right? And according to rational root theorem, according to rational root theorem, the possible roots of the polynomial, which is denoted by R, the possible roots of polynomial is equal to
P is equal to the factors of P over
P
the factors
over is equal to the factors of P over the factors of Q. Okay. The possible roots of
a
a polynomial
is equal
to the factors of P over the factors of Q. Now you might ask, what are the factors of P? What is P and what is Q? So P is
this one.
It is the coefficient without any x. That is P. And Q, it is
the coefficient
the
that
coefficient
is
that is here
on
on
the
the x with the highest degree, and the x with the highest degree is x to the power 6.
So it has a
So it has a
coefficient of 1, right?
coefficient of 1, right?
It has a coefficient
It has a coefficient of 1. So that is
q.
That is
So I've
Q.
said
Okay.
P is
So I've said
the
P
coefficient
is
without
the
any
coefficient
x,
without any x,
Q
and
is
Q is
the coefficient
the
on
coefficient on the x with the highest
So
degree.
according to
So
rational root
according to
theorem,
rational root theorem, the possible roots of this polynomial,
the possible roots
of this polynomial
are equal to
the factors of P, which is 2,
divided
divided by the factors of what? The factors of
divided
by the factors of Q, which is 1. So what are the factors of 2? Numbers that can go into 2 without leaving a remainder. We know that those numbers are plus or minus 1 and plus or minus 2. And for the factors of 1, it is just plus or minus 1. Okay?
So from that, the possible roots.
So from that, the possible roots.
Okay, guys, I think I just I'm a bando hapa. Let me just switch SIM cards. I go to Zamteo. I don't know how they
I don't know how they connect. Can you get me?
It's tripping, but yeah, now we can.
Anatolewa mvuto wa 1-1.
I'm trying to switch How about now?
Pangaja.
How about
Overkill. Sanfwa confident tu. So cool I said connect. Today.
Yeah, I'm a bando hapa, so I'm switching.
yeah, I'm a
I'm switching to a different. I'm switching to a different phone. Okay, can you get me properly?
Okay, can you get me properly this time?
Yeah, what time are we going to upload that one for photograph? Because 23:30 I have to dip.
I was hoping that tupwe kumanani kan.
Yeah, I was hoping that tupwe kuma nani kan. I was hoping that tupwe kuma 23 because I also have to study. But we'll see ayadi panani kan pa next time.
So aga pepa na lebu tukakari na simu. Umulondanda wa muntu lesoma bati database.
Okay, you can get me clearly now.
Okay, you can get me clearly now. We can continue.
Yeah, we can continue.
Okay, so
we're saying that you need to find
the factors of P, where we said P is 2 here, and the factors of what? The factors of 1, which of Q, which is 1. And I've said that okay, we know what I explained here. So all we need to do is divide now. So when you divide 1, plus or minus 1 divided by plus or minus 1, you just get plus or minus 1, right?
When you divide
plus or minus 2 divided by plus or minus 1, you just get plus or minus what?
2, right?
2, right?
Okay. Yeah, so these are the possible factors.
Yeah, so these are the possible factors. The possible factors when you are trying to solve this polynomial function, the possible factors are -1 +1 minus 2 plus 2. Okay, so
these are the possible factors. When we say possible,
it means some of these are not factors, some of these are factors. So if one of these is a factor, when you replace it in the original polynomial function, you should get what? 0, right?
When you replace a factor in the
original polynomial function, you should get 0. If you don't get 0, it means that that is not a factor. So let's try any of these. Which one should we try? Let's try when x is equal to 1.
-1.
Not negative 1. Why do you want negative 1?
Okay, so let's try
x is equal to.
We try x is equal to what? Okay, x is equal to negative 1.
Okay, x is equal to negative 1.
So,
I'm guessing a phenomenon of about 6.
now guys, can you
compute this?
Is what
will get equal to 0. I know here we'll get 1
to be plus 1 minus 4 minus 2 plus 5
plus 5
plus 1
-1.
equal to 0.
0.
Yes, it is the one.
It is a factor.
Yes.
Okay.
Okay, this one and this one. Guys, are you sure?
Oh yeah,
it is a factor.
Right.
So we'll get 0 is equal to 0. If we get that, it simply means that
It simply means that
x
minus 1
simply means that x minus 1
it's x plus 1.
It's x plus 1. X plus 1 is a factor.
Or you can say
x
is equal to what?
X is equal to what? Negative 1
right?
is a factor, right?
Yeah, or you can say that.
Yeah, or you can say that. So once you have your factor, you can now use that to try to divide in this polynomial function. Try to reduce it.
So I think
the best that we can use
in our case is synthetic division. So my factor is
according to what we found is x is equal to what? Negative 1, right?
What I wrote here.
Is that what I wrote here? Oh yeah, that's
So
what I wrote.
that is
our factor. And using synthetic division,
we're going to say
x to the power 6, x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0, and we're going to write the coefficients. This one has a coefficient of 1, this one negative 1, this one negative 4, this one 2, this one 5, this one
negative
negative
1, this one
1, this one negative 2.
and we are
dividing this by
we are dividing
this by x is equal to what?
x is equal to
X is equal to
1,
negative 1, right?
So here
we know that we just
for the starting
for the first one we just drop it like that. So it will just be 1. You just drop it like that.
For the first one, just drop it.
For the first one,
And,
just drop it. And
what you do from there is
you say 1 times negative 1.
So it's basically
this one times this one. And what you get from there is negative 1. And you say negative 1 plus negative 1, you get negative 2. Negative 2 times negative 2 times negative 1, you get 2. 2 plus negative 4 plus 2, you get negative 2. Negative 2 times negative 2 times negative 1, that is 2. 2 plus 2, that is 4. This times this, that is negative 4. You get 1. You get negative 1. You get negative 2. You get 2. You get 0 as your remainder. And what you remain with is x to the power 5 minus 2 x to the power 4 minus 2 x to the power x to the power 3 plus 4 x to the power 2 plus x minus 2 is equal to 0. That's what you are going to what? That's what you are going to get.
So this is what
you are going to get
once you
deal with that.
we've already found x.
So remember, we have already found x.
Already found one what?
We have already found one what? One x value. So we have remained with this.
So what we need to do here is
repeat.
So
Yes.
this statement means we have 5 possible factors and we have to use rational root theorem again to find the possible factors for the new equation, and then do it 5 times to find the same factors.
So I think Mpasana will end somewhere by number 3.
But
we use factor theorem again. You say R is equal to P over what? Q. And we know that
our P is 2.
Our P is 2 and our Q is what? 1. So we get the factors of 2 over factors of 1. We basically get the same things if you remember. The possible factors are still going to be negative 1, plus or minus 1, negative 1 plus 1, negative 2, plus 2. These are going to be our possible what? Our possible factors. Okay, these are going to be our possible factors. Then we test again. We say try, and this time around, which one should we try? Should we try 1 when x is equal to 1 or when x is equal to which one should we try?
Try 1.
So we try when
okay, so we try when x is equal to what?
To 1.
To 1.
Place in there.
we replace in there. So it's just basically 1 to the power 5 minus 2, 1 to the power 4 minus 2 plus 4 plus 1 minus 2 is equal to 0.
Okay, I can see that this one
and this one is cancelling.
This one and this one.
It is
This
the
one and this
It's a
one.
factor.
It's a factor.
yes.
Is it me who has made the mistake?
Is it me who has made the mistake of writing?
Let's try to go through.
Guys, how is it a factor?
Guys, how is it a fact?
One.
1.
Are you sure it's a factor?
Are you sure it's a factor?
It's not a factor.
It's not a factor.
It's not a factor.
Nope. X is equal to negative 1 is a factor.
X is equal to negative
X is
1
equal to negative 1 is a factor.
Okay.
Okay, let's try that one according to Nsamo. When X is equal to negative 1, we'll get
One.
Yeah?
One it is a fact.
One was also a factor.
1 was also a factor.
Let's try this.
Negative 1.
Okay, someone let's try this.
Okay, so
Let's see what we're getting here.
we'll get negative.
We'll get negative.
We'll get negative 1.
We'll get negative 1 minus 2 minus plus 2
plus 4
plus 4 minus 1 minus 2 is equal to 0. Which ones are cancelling? This one and this one is cancelling. This one is a factor.
Because if you get
this one, and this one, you add, what you get will be 4 minus 4 is equal to what? To 0. This one will give you 0 is equal to 0. Now you guys who are saying that even 1 was a factor.
Let's go through even. Let's try one first.
1 is not a factor.
Oh,
Yes, because okay. Oh, you can try it. That's okay. This one is not a factor. Because of the
1
5
minus
it's an odd number.
minus 2 plus 4 plus 1 minus 2.
one.
Guys, isn't it also
Guys, isn't it also a factor?
you people?
It is a factor.
It's a factor.
It's a factor.
Hey. Try. There negative 2, which is negative 4, minus 2, which is negative 6, and then 4 plus 1 is 5, plus 1 is 6.
Okay, so if you
So 6
Okay,
minus
so if you
replace 1 here,
replace 1 here, you get 1.
Here when you replace 1 minus
Here when you replace 1 minus 2 plus 4 plus 1 minus 2. Okay. This will cancel with this.
Yeah, it's also a factor.
This will cancel with this. Yeah, it's also a factor.
So either way, it works. You can choose 1.
So either way, it works. You can choose 1. You can choose negative 1. It works.
You've heard?
You've heard?
I've said that either way it works. You can choose.
I've said that either way it works. You can choose.
Okay, which one would be easier to handle?
Okay, which one would be easier to handle? I think when X is equal to 1 is easier to handle when it comes to the synthetic division. So we'll choose this one.
So we'll choose this
Okay,
one.
so we'll choose this one.
And
we'll say that let me come back here
and use this space
and use this space for
for my
my synthetic division.
So here I'll have
So here I'll have 1, -2, -2, 4,
minus 2,
of 1 minus 2,
we are using
and
when x
we are using when x
how is the network, guys?
how is the network, guys? Is it lagging?
No, it's not.
Okay.
So
We are using
when x is equal to 1. So we
let me remove this. We simply put a 1 here.
We put a 1. We know for the first one we just drop the 1, and say 1 times 1, we get 1, get minus 1, -1 times -1 times 1, we get -1, we get -3, get -3, we get 1, we get 1, we get 2, we get 2, and we get 0. Okay, so another way of proving that if knowing that you made a mistake is when you try to do the synthetic division, it won't give you 0 here as a remainder. If what you chose wasn't a factor, it won't give you 0 as a remainder. Okay, so that's a point worth noting.
Yeah, that's a point.
Yeah, that's a point worth noting.
All right.
So what
Guys,
So
can
what
we
we
skip to the graphing part?
okay.
Taking of time.
okay.
Because this one, we've just found the second factor.
Yeah, okay.
Let me just write what we're remaining with and see what the majority vote is going to be. So
essentially what you're
going to do again here, we found the second factor to be x is equal to what? X is equal to 1 again, right?
So
Yeah. So essentially what you're going to do is that you're going to repeat and repeat and repeat until you do what? Until you
reach
at a point. Yeah?
Until we reach on the 6 factor.
Until we reach
on the 6 factors. So again, you're going to use rational root theorem. So I don't know. Guys, Jerome wants us to go back to that question that we left. I don't know if that's the majority vote. I don't know if you guys have understood the concept here. We can move away from this question.
What question?
This same one.
He wants us to move away from it, since we are just repeating the same thing. Wants us to go back to the graphing question that I left.
Yes, let's graph.
What was on question 3? Anyway. Wants us to go back to this one.
the majority
So
vote.
is that the majority vote?
Where's Daniel? Is Shadrach?
Where is Daniel? Is Shadrach?
We got to this one.
We got to this one.
Yes, we can craft. Yes, yes, yes.
All right.
All right.
This question is just saying.
This question is just saying graph the rational function.
Okay. So the function
So the function is
f of x
f of x is equal to x to the power 4 plus 4 over x minus 3 x plus 2.
So we need to
Right.
graph this.
So we need to graph this one.
So
So
how do we go about graphing?
how do we go about graphing this one?
Firstly,
We know that we need to find the vertical asymptote. We need to find the horizontal asymptote, and when we do that,
we can
we can graph, right?
Right. So
Right. So I think if you look at the denominator for this question,
it was
already simplified for you. So when finding the vertical asymptote,
you just
equate the denominator to what? To 0. Since it's already even simplified for you, you equate it to 0. What you get will be x is equal to what? 3, and x is equal to negative 2, right? Yes, this is going to be our vertical asymptote. These are going to be our vertical asymptote. So if let's say the graph was here,
our
asymptotes would be at negative 2 and at 3. So the next thing that we would want to do is find the horizontal asymptote. And for the horizontal asymptote, there are conditions that we follow.
We know that.
Okay, let me write the function like this. X squared minus 3x x squared plus 2x. I'm just expanding. Don't worry, I'm just expanding. Minus 3x minus 6. So this is the same as x to the 4 plus 4 over x squared minus x minus what? Minus 6.
Okay.
We understand that I've just expanded, right? Yes. Okay. So I've just expanded the function, and I just want to demonstrate the type of asymptotes that we have here. We know that when the powers are equal,
when the powers are
equal,
your asymptote
when the powers are equal, your
asymptote
asymptote is just going to be the division of the coefficients when the powers are equal. So let's say if here we are the 2, here we are the 3, our asymptote would have just been 2 over 3 if the powers were equal, right?
or if
it is like this.
So
that is for when the powers are equal.
So if
the powers were equal, we would have had an asymptote of y is equal to 1. Now the powers are not what? The powers are not equal.
When
the power on the x
of the
denominator is higher.
So if
this one was higher
than the power
that is here, our asymptote would have been y is equal to 0, right?
Jerome. Shadrach, am I lying?
You're right, sir. You're right.
Yes. So when the power
on
the
denominator
is higher
than the
x power on the